Well, industrial steel treating started somewhere between 1944 and 43. Charles St. John's started the company, and it was located on Chittick near Francis Street. At that time, it was just a small little shop with just a few employees. And they were just doing some basic heat treating with salt bath furnaces, which you won't see any of those today. They moved to this present location in about 1947. And we came aboard in the latter part of 48, early 49, when my father and Louis Glick and Charles St. John's formed industrial steel treating.
We don't run the processes that were employed at that time. Those were salt bath furnaces, which is a molten salt contained in a refractory that the parts are dipped into to heat and then pulled from and dumped into an oil tank to quench, to cool the parts. Today, the equipment is all atmospheric controlled, and the parts enter the furnace in baskets that are loaded by individuals or dumped onto belt furnaces that are also loaded by our employees.
The process control portion of what we do is really evolved from inspecting quality into the part, meaning checking a lot of parts and verifying that whatever we did was correct, to really monitoring the process, watching closely what goes on.
Today we're going to take you through a tour of industrial steel treating from when parts come in the door through the final shipment. This is our receiving inspection department at Industrial Steel. Parts come in through trucks, as you can see over here, and our shipping personnel takes them off the trucks and weighs and piece counts them and enters them into our computer system here. Weighs each order up. This is an area where we have finished orders. These parts have completed processing and they're ready to be picked up by or taken out of our trucks to designated areas, or customers' trucks will come in and pick them up. This is a pre-wash. We call it a Ransohoff washer, and the parts that need to be pre-washed for heat treatment are washed through this Ransohoff type washer here and collected into our IST hoppers and then taken to the designated places where they need to be processed.
All these parts, myriad of parts that come in, they all have requirements by the customer of whether they want them just hardened, a hard surface for wear resistance, or if they want them toughened. So there's an optimum combination of properties of strength and ductility.
We have been known for getting people out of jams with regards to production requirements that can't be achieved other places. Other heat treaters cannot meet what we do here. We have a very diverse set of furnaces that we maintain with the ability to move back and forth to handle any rush situation, which is very important today because it's all about getting parts to the customer quickly. And I think that we do that very well.
But every customer has a specification on the part that they send us, either dimensional or metallurgical. They put their trust in us that we're going to carry out whatever is on their blueprint.
This is our batch department at Industrial Steel. We have 3 batch type furnaces, which you put the load all at once, and it has a computerized program depending on the parts that you want to process and what it requires: carburizing, annealing, neutral hardening. This is all identified on computer, and we have computer sign-offs for each step for the people to perform. These furnaces they have a special gas that we make here in Industrial Steel. It's endothermic gas. that we make in our generators that we have here, to where we take air and natural gas and superheat it to 1800 degrees, and it cracks, and then we critically cool the gas to form endothermic gas, which consists of hydrogen, nitrogen, and carbon monoxide. As you can see, these flow scopes control the amount of gas that we have in the furnace: endothermic gas, natural gas, air, ammonia, depending on what the process that you want to put these parts through. How do we monitor them? There's a computerized program for each kind of part, and it will mimic the program. When the parts are ready to come out, an inner door will open, and the parts will, there's a pushing system that pushes it into a quench chamber to where the inner door closes, and the load is then submerged into an agitated special type of oil. That is what hardens the steel when you cool it very rapidly.
During the course of 1950, 60, 70, we enlarged the business on a continuous basis. And we found ourselves in the 70s with probably over 300 customers on our customer list. And of course, at the old adage, 80% of your customers produce 20% of your dollar volume, or the converse. We didn't have engineers here, we just had the different disciplines that management, and then we had a lot of intuition on the floor, and they knew what to do and how to do it, and we built equipment that we could handle the whole thing for GM at the time. So that, after about 1981, we were doing all their work before they got their own equipment installed in Columbus.
Well, today we specialize in carburizing, carbonitriding, neutral hardening, carbon restoration, annealing, and induction processing. We do this in batch furnaces, continuous tray furnaces, belt furnaces, and in our induction equipment.
I think the key to success in a commercial heat treat is that ownership is active in the business. It's been demonstrated within our industry when heat treating is franchised. If you don't have that local ownership, that local control, generally speaking, the business will not be successful. I think it's crucial that the upper management knows what goes on a day-to-day basis and can get people what they need, respond to those issues immediately in order to be, in our industry anyway, truly successful.
After the parts come out of the furnace, there's a special charge car that goes up and down these tracks to pull the loads out of the furnace and bring them down here and put them through this post washer so that we wash all the oil off the parts. And then we take samples into inspection, check them for the as quenched condition, and then if it requires, we will temper the job in one of these 3 batch straws that tempers back to harden, depending on what the requirement of the job is. This particular part requires it to be stacked so many pieces a layer and a certain type of screen in order for it to turn out. This is our belt department at Industrial Steel. We have 3 4,000-pound-an-hour belts that we use out here to process parts in that require belt processing. As you can see, we monitor temperature, carbon, oil temperatures, where the parts are in position of the furnace. This is an inline process to where you start, the parts will pre-wash, go through the belt, are quenched, part back to the final Rockwell C hardness.
We work with other firms so that those jobs that have to go from heat treatment, the next step being, in the case if there's a next step, it would be plating or whatever. So we work with a network of suppliers that do that work. So we don't do any of that here, just heat treating.
Results are much more predictable today, and it's because we're controlling the process and not inspecting the quality of the product after the process is complete. Really paying attention to that control and getting that immediate feedback from your information systems on the process is what leads to a perfect product.
This is one of our quality inspection labs at Industrial Steel, to where we bring our samples to check at the various stages of the operation, usually as quenched, or as received, as quenched, and final inspection. Samples are brought in from designated furnaces throughout the shop to where we inspect our work in here. This is our receiving department at Industrial Steel. Work comes in off these trucks, and our guys will take them off, weigh them in, put them into our computer system, and then take the jobs to the designated areas as to where they need to go. As you can see, this is where some of the finished product is, waiting to be put on trucks and shipped out of here. They've already been processed and ready to ship. This is our quality inspection lab at IST West. Typically, it's the same as IST East. Rockwells for checking parts, the hardnesses of them. Micropress for mounting and prepping samples that when we need to evaluate microstructure. This is a computerized schedule that we have here. These are the jobs that they will run in order in the furnaces.
So, you know, it always starts with the people that you have and how gifted they are and how smart they are, how diverse their capabilities are. It starts right there. The information that we give them and that is timely and correct, and that they have the freedom to make decisions with on the day-to-day basis, really helps us to satisfy the customer needs very quickly.
We actually have a customer that has a patented product that is used in construction sites, heavy construction, bridges, buildings, windmill applications, a patented product that measures the tension of bolted joints, something that's relatively novel. We heat treat these parts for them, and they go in, as I said, bridges all over the world. They're at Ford Field, they're at Comerica Park.
This is a P9 pusher. We have two of these pusher type furnaces at Industrial Steel, and as you can see, the baskets that we have and how we've loaded the parts in them, there are 9 positions in this long chambered pusher furnace. And same concept as across the street. Endothermic gas, which is produced in these generators right here. And this is the blanket gas that is plumbed into these furnaces, to which the carbon potential is controlled by air and natural gas to the carbon potential that you want to set depending on the job that you want to run. As you can see, the guys got the loads up on the rollers. They go down the line. There's a pre-washer. Parts will automatically go into there and come out and go through a preheat. Parts are preheated at 750 degrees, to which they are then cycled through this P9 pusher furnace, 9 positions long. As you can see, we control the process, monitor and check it every hour, temperature, carbon, oil temperature, part tracker, that tracks parts through the furnace. What you're looking at is through a side glass, of the last zone in this P9 pusher. That's 1,550 degrees. A load will travel down there, and when it comes time, that inner door will open, and this giant pusher here will push this load into the quench. Oh yeah, pushing that load all the way into that quench chamber. Now it's coming back. It has so long to travel, and the limit switch will tell that door to shut, just as you saw. Now that load is going down into an agitated quench bath, so it cools very rapidly.
Well, the self-tapping bolts is a specialty, and high volume, high quality automotive components. This is all automotive, basically. Our equipment, there's no other industry really that will satisfy the appetite of our equipment. Automotive is high volume. So we had to build our equipment that way to be competitive.
You know, every time we see a Ford truck on the road, an F-150, F-250, F-350, the bolts that you see that hold those bed boxes in place, we heat treat. A lot of the latches on those vehicles, on the Ford vehicles, that hold the doors in place, we heat treat. The bolts that hold the seats in place, more than likely we're the ones that have heat treated those.
We do export to Canada, our northern neighbor. Some of our customers do ship product that we heat treat into China, GM facilities for assembly. And interestingly enough, some of that material is then returned back to Toronto for assembly into an engine and then sold into North America. So we don't have any customers offshore, but our customer base exports the products that we heat treat.
Here you go. Don't worry about the little puff. You'll be okay. See how that endothermic gas burns off when it ignites with oxygen? That load has gone all the way through the furnace, quenched. It's coming out, and now you'll see it travel down these automated rollers into a post-wash. This load will be washed, dunk washed, and sprayed, and at the end of its cycle, come out and automatically go down these rollers to our tempering furnace. The parts will travel through this tempering furnace, depending on what the job requires and what temperature, come out this end. When the parts are completed by the tempering, they come out here. One of our gentlemen over here will pack these parts back into hoppers. From here, the parts will be put into their tubs and inspected and okay to ship. This will preheat the parts to 750 degrees before they go into the beginning of the furnace. As you can see, the flame burning off here is endothermic gas. It's the protective gas, again, that we make here in our generators. This is the blanket gas for these belts so that the parts will not scale. We then control the carbon potential with natural gas and air. These parts are carbon nitriding, so we're adding carbon to the steel. So we have to have it usually set at 1%, a higher carbon potential than what the steel has. This is the 5K belt furnace from the very end of the furnace. You're looking at parts that are processing through the furnace at 1,650 degrees. This is one of the parts parts that has fallen into the quench and come up approximately 15 feet. As you can see, it's about 110 degrees right now. It's in the hardened condition because it has cooled so rapidly. Through the wash system and onto the tempering belt where the parts will travel to a temper. They'll be tempered for 250 degrees Fahrenheit for what the job requires. This is where the finished product goes, designated shipping area. When it's completed, shipping will inventory white tag it out. It'll be ready to be picked up by the truck. So our trucks will take them to their designated location.
If you recall, there was an ad a couple years back where a Ford truck is actually suspended by a crane being held by one bolt. The bolt that, as I mentioned, hold those bed boxes in place. And that was a part that we heat treated. And we didn't know it until we saw the ad, but that was our part, so it was pretty cool.
We have an enormous amount of processes that we can perform for Michigan, Ohio, Indiana, Illinois customers. And we see continued investment into this organization.